Hello, PreCalc. This is the 921 edition of Pre-Calculus. You'll be viewing that Wednesday after class. And we're going to do some more examples of trig in real life, how to use it to figure out stuff. For example, say there's a bike path along the water. Sounds refreshing. Sounds like a field trip idea. Let's find a bike path that we can all bike on by the water. It'll be a trig field trip. Come in with some suggestions. Alright, so here's a bike path, and it goes along the water, and then zinging off the bike path is a walking path to the lighthouse. And we'll draw another line. We are able to establish the distance from the lighthouse perpendicular to the water's edge is 180 yards. We'll say that this walking path section is 600 yards. And I want to find the angle that the bike path makes with the walking path. So I'm looking for this angle right there. So I'm going to design a little garden right there, and I need to know the angle before I can design it well. So let's go ahead and pull out some trig out from up our sleeves. Alright, so I notice that the angle is what I'm looking for, and I know the side opposite the angle, and I know this side, which being opposite the right angle, is the hypotenuse. So what trig function will have angle, opposite, and hypotenuse? Sine of theta equals opposite over hypotenuse. So we don't know theta, we do know side opposite, and we know hypotenuse. So subbing in the numbers given, we have sine of theta is 180 over 600. To figure that out, let me get 180 over 600. Calculator, 180 divided by 600 is 0.3. Sine of theta equals 0.3. Now 0.3 is not the answer, but the angle that has a sine of 0.3 is the answer. So yesterday we talked about one of these in the video. So do you recall what button it is? It is the inverse sine. So the calculator knows what angle has a sine of 0.3. So you go to second sine, it'll take you above to this symbol, sine to the -1, inverse sine of 0.3. And that's what it looks like. And hit enter, and we get a value of 17.457. I'll just cut it off at 17.5. So that is the angle that I found in between the bike path and the walking path. Alright, let's do another one. Zoom over here. Alright, over here we have our nearby neighbor in our neighboring town, Washington, D.C. Field trip. So we have the Washington Monument. And has anyone walked up the Washington Monument? For years it was under construction or renovation from an earthquake damage. But perhaps you have walked up it. And you're wondering how high is the building. But it's very difficult to measure from being on the ground or at the top. So we can come a certain distance in front of it and mark it. So we could measure that. So marking from here to here, we are standing right here, and it's 115 feet away. So we could bring a tape measure and use that tape measure multiple times and establish a distance away from the base, 115. Then we could bring an instrument like a compass or a protractor. I always forget which is which. It's pretty sad. Let's say it is a protractor. You can tell me tomorrow if it's not. But anyway, the thing that measures angles, and you can set it up, and you can find, and you can sight from where you're standing to the top of the Washington Monument, and you can get an angle on your instrument, 80 degrees. There's probably an app for that now, so let's go ahead and use the information known to find the height. So from the angle, height is side opposite, and at 115 is not the hypotenuse because it's not across from the right angle. It's next to the angle, and it's side adjacent. So what trig function is that? Tangent of theta equals opposite over adjacent. So we can write in tangent of 80 equals the opposite, we'll call height for the unknown, over adjacent 115. To solve that for h, we simply multiply both sides by 115. 115 disappears from the denominator in the right, and it reappears in the numerator on the left. So I tap that out. 115 times tangent 80 Alright, I get 652 feet. Alright, so 652 feet. I have no idea if that's right. I kind of made this problem up, so somebody look it up and tell me how high it actually is. Probably someone could give you, these I made up, so someone could give you real data and you could get the actual height of the Washington Monument. Alright, it really doesn't help much watching me do problems, so I'm only going to do a few tonight, these two, that's it, and just give you the gist of what you're going to be doing when you read the problem. Just be aware that when you look at real life problems, you're looking for a right triangle, and write down what parts are given. You'll decide what trig function will get you the rest of the answer. It's as easy as that. All right, have a good evening. See you tomorrow.